So what exactly does Designer SIP do? This is kind of the sales and marketing slide. So we talked about the system in package technology. Because we use wire bonds based on gold, we don't actually need lead in the process. And in all honesty, we're based on our testing and the projects that we're putting it in, we're finding that it's as reliable or more reliable than using a leaded system because you don't really have to worry about cold solder points. Of course, now being test guys, we also know how to do this integration so that we can test it to make sure it works before it even leaves our door. And then talking about interesting spaces, when we started off the Designer SIP business line, I was sort of going around talking to people. The first people we went to talk to is oil and gas. Everyone talks to oil and gas in Alberta, right? They have the money. Oil at $75 a barrel, Syncrude's still making it at 25, right? It's a good source of revenue. But what we started to find is that Alberta actually has a lot of advanced technology that's sort of in non-traditional spaces, and that's what I call the interesting areas. Agricultural is one of them. There's actually a fair bit of stuff that goes on in the inspection space. But they're all sort of interested in this, and one of the projects actually we're just kicking off is essentially taking wireless sensor networks into an industrial space, but actually making it quite a bit smaller than the existing solution. And the best part about it is the existing solution is American, and we're planning to kick their butts because it's going to be smaller and easier to use, right? And that was our edge in terms of getting the contract. Now, one of the nice things that comes in terms of having our own chip technology as well as sort of leveraging, I guess, the physics of having shorter traces and not having to drive quite as big a line, is that we can improve the battery life for these systems so that, keep in mind that a lot of these are battery-operated systems, that in terms of having to last, half a year or a year without needing replacement, you really need to be able to do the power management nicely, and we've been focusing on that space as well. And we talked about the reliability in harsh environments because, if the system is failing, it doesn't matter, if it's, processing as well as it should or whether the battery life is good. If the electronics is failing, you're going to throw it out. So we've really been focusing in terms of building the electronics so that they last longer. We've sort of been focusing on the packaging side as well. And it's actually been kind of interesting because a number of the companies in Alberta were originally sending their packaging to the US, where if you're familiar with how packaging works, essentially there's a silicon die, it gets glued into a package, gets bonded out, and gets sealed. And that process works great in sort of the industrial range, which goes up to about 80 degrees, but as you start to get to more of the extreme temperatures, you get temperature coefficient differences that essentially break these chips apart and causes the system to fail. So we've been using different techniques in terms of packaging to essentially help these modules last longer. And I think it's pretty much lunchtime because I'm done. So. And I apologize for the speed. Come back and catch me later. I know I hate to be the presentation before lunch, but at least you're not sleeping.
Yeah. Thank you very much, Noah. Anyone have any questions for Noah?
I might have missed it, but what do you use instead of the lead bond for the circuit board?
So, use an epoxy. If you're in the system package model, you epoxy the die on the component and then use gold bonds or aluminum bonds. Gold generally tends to work better, and then your gold is actually your electrical contact, and the epoxy holds it in place quite nicely, actually.
So it's welded?
No, it's like glued on. Yeah.
I think he wants to know how the bonds.
The gold isn't glued on.
No. It's essentially in a, I guess layman's terms, crushed on. That's probably good.
We can tell you a little bit about that process later on. Okay, thank you very much. Any more questions, by the way? Any more questions? Good. Thank you very much, Noah.